Alright, in this video we're going to talk about kinetic energy. So what kinetic energy is, it's a specific type of energy that's associated with motion. So in order to have kinetic energy, something must be moving. So anything that is moving will have kinetic energy, and anything that's not moving will not have kinetic energy. So as you're watching this video, sitting in your chair, you don't have kinetic energy in the classical physics sense that we're going to worry about. So what does kinetic energy depend on? Well, we're saying it has to do with motion. So one factor that affects kinetic energy is the speed. So the faster an object is moving, the more kinetic energy it's going to have. So that's an important relationship to know. The more kinetic energy you're going to get is going to come from a greater speed. And another factor that influences kinetic energy is mass. So the greater the mass of an object, the more kinetic energy it will have as well. So both mass and speed have a positive relationship with kinetic energy, meaning that if we increase mass, the kinetic energy will increase, and if we increase speed, the kinetic energy will increase as well. So if one goes up, the kinetic energy goes up. All right, and the formula for kinetic energy kind of confirms that. So if we have mass times velocity squared divided by 2 to give us kinetic energy, we can imagine if we take a bigger number for the mass and multiply it here, it's going to give us a bigger number for the kinetic energy. And by the same token, if we take a bigger number for the velocity, that's going to give us a bigger number for the kinetic energy as well. So both mass and speed or velocity, if we increase them, we're going to increase the kinetic energy. All right, so in terms of those things, mass and speed, let's think about how in these certain situations kinetic energy might be impacted. So if you want to pause the video right now and maybe take a minute to think over these questions on your own, I'll give the answers now. So the object A here has a mass of 10 kilograms and object B has a mass of 20 kilograms, and they're moving at the same speed. So which of them will have more kinetic energy? Well, we just said the more mass an object has, the more kinetic energy it's going to have. So in this case, object B would have the greater kinetic energy because it has a greater mass. And it's important here, the speed is the same. If we change the speed as well, we would have to use the kinetic energy formula to actually calculate what difference the speed and mass would make in terms of the kinetic energy. But if we know the speed is the same, the only thing changing here is the mass. The greater the mass, the greater the kinetic energy. So object B here with the greater mass would have more kinetic energy than A. So C and D down here, we have objects C and D that have the same mass, and this time they have different speeds. Object C has a speed of 5 meters per second, and object D has a speed of 2 meters per second, which will have more kinetic energy. So in this case, the mass is staying constant, so that doesn't affect it. All we're looking at is the speed, so the faster object would be object C. So the faster an object's moving, the more kinetic energy it's going to have. So in this case, object C would have been faster. All right, so let's try and do some calculations using the kinetic energy formula, which again is kinetic energy equals mv squared over 2. Or if some of you maybe like fractions, you can write this as 1/2 mv squared. It's really the same formula. Whichever way makes more sense to you is fine. All right, so we have a car here with a mass of 4 kilograms, and it's traveling at a speed of 10 meters per second. What is its kinetic energy? So all we have to do is take the information from the problem and plug it into the kinetic energy formula. So we have the mass here of 4 kilograms, and we have the speed or velocity, which is 10 meters per second. So these are all the pieces of information we need to plug into this formula over here to solve for kinetic energy. So we plug in the mass is 4, the velocity is 10, and we have 2 on the bottom there. So when we're solving the kinetic energy formula, there's one very important thing to keep in mind, and that is PEMDAS. So everybody probably remembers from math class, PEMDAS means parentheses, exponents, multiplication, division, addition, and subtraction. So in this case, we have to keep this in mind when we're solving the kinetic energy formula. So here we have exponents that need to come before we do any multiplication or division with this. So we do the exponent first, and 10 squared would give us 100. And then we have the 4 out here still, and the 2, and everything else just gets carried through. So to solve from here, we have multiplication and division left. In PEMDAS, they're really on the same level. So we can just do the multiplication and division here, and if we multiply 4 times 100 and divide by 2, this would give us 200 for the kinetic energy here. And as with any form of energy, our units are in joules. So 200 joules would be the kinetic energy here. Alright, so there's a couple more calculations here. If you want to maybe pause the video and try these out on your own and see if you can figure them out using the kinetic energy formula, which is, again, mv squared over 2. So if you want to try these out on your own and then come back and I'll go through them as an example. So we have Joe walking to school here. He's got a speed of 2 meters per second and he has a mass of 40 kilograms. What is his kinetic energy? So in this case, we just want to plug into the formula. We have the mass of 40 kilograms and the speed is 2 meters per second, and divide by 2 on the bottom here. So to solve this, again, we have to do the exponent first because of PEMDAS. So we have 2 squared would give us 4, times 40 would be 160, divided by 2, that would give us 80 joules for the kinetic energy here. The second question here, what is the kinetic energy of a 1.5 kilogram ball that is thrown at a velocity of 20 meters per second? So same thing here, we have the mass, we have the velocity, we just have to plug into the formula. So we have mass is 1.5, the velocity is 20, and again divide by 2 because of the kinetic energy formula. So to solve this, again, exponents first, so we do 20 squared, that would give us 400, times 1.5, 600, divided by 2 would be 300 joules of kinetic energy in the second problem. So the kinetic energy formula, it's not too different from any of the formulas we've seen so far this year. The only big difference here is we're using an exponent. So the biggest key with the kinetic energy formula is to make sure that you do the exponents first before you do any multiplication or division. If you try, in the case of this problem, if you try and multiply 1.5 and 20 first, it's going to be wrong. It does not follow order of operations. All right, so we need to do the exponents first and then multiply and divide afterwards. All right, thanks for watching this video on kinetic energy, and I'll see you in the next video.